guys, let's take a look at our next measures. Last 2 days we've been looking at measures of center with mean, median, and mode. Today we're going to move on and look at measures of variation. So a measure of variation is really the measure of how far the data is spread out. Okay? How far it is apart from each other. And that, again, just like how close it is to a central number and how far apart, tells me a little bit about the data and how reliable it can be, or how much information I can gather from it, or how it was collected. It gives me a lot of information that I can use then to determine the validity of my data. And that's really important as we work with statistics, because you'll see as we continue to grow up and get older is statistics can be really meant to show you anything, can be modified, can be manipulated so that you see what they want you to see. So let's get some vocabulary out of the way. First things first, one of the measures of variation is the quartiles. A quartile is really just what it sounds like. It's split up into 4 parts. And the 3 data points in the middle, if I have 4 parts, these are my quartiles. I'm going to look at what's my second quartile, right here in the middle, Q2, my third quartile, and my first quartile. Okay? So those are my 3 pieces, and I've got my 4 parts here. Okay? Our first quartile is exactly what it sounds like. It's the 25th percent of the data, where the second quartile is the 50th percent of data, and my fourth quartile is my last 25% of the data, which actually would be the 75th percentile, is really what we're 75% of the data for that given set. So those are the numbers that we're kind of looking at to talk about measure of spread. How far apart is it? Are they equal distance from each other? Those kinds of questions we'll discuss as we continue to work on it. Now, we've got those 3. In addition to that, we've got something called the interquartile range. So if we go back to that same diagram I showed you a minute ago, if this was Q3 and this was Q1, the interquartile range is the distance between these two. So how far from the 75th percent of the data to the 25th percent of the data, where most of the data probably will be located. 50% of your data would be listed right there in the middle. The range is the distance on the entire thing. So it's from the greatest to the least. There's my range, the difference between the least and the greatest number. And then we have outliers. Are there any numbers so far out they vary significantly from other observations? And really what that means, this word significantly means, is we're looking at the IQR times 1.5. That's how we know what significant means. That's got to be the definition so that we all have the same definition of significant across the board. Okay? So if you need to pause the video to get any of these down, that's fine. I'm going to go ahead and move to the next question. So this just gives us more information. All right, so let's talk about our measures of variation. So every time you hear the word measure of variation, you have 6 pieces of data to come up with. You've got to come up with our median, which is our Q2, our Q1, our Q3, our IQR, and our range. In addition, you're also going to come up with to see if there's any outliers. Okay? We're really going to focus more on outliers on the third and fourth question of the lesson. Both of these, neither of the first 2 have an outlier. So we'll come back and really dig into them on the next 2. So the first thing I do for median, and that's my first step, is to find Q2. Okay? So this happens to be in least to greatest form. Q2 would be sitting here because it's even. So I find the difference between these 2 is 5. So half of that is 2.5. So I say my median is 27.5, or 27 5/10. Now to find my Q1, I take the lower half, that's this half right here, okay? And I find the middle of my lower half. And it's as simple as, look, what number is in the middle? And this time, it's 8. So my Q1 is 8. Then I have my upper half, okay? Of my upper half, that's the top 50% of the scores. I find the middle, and in this case, it's 50. So my Q3 is 50. I'm really finding the median of both those 2 sides. Now I do my IQR, it's just simply 50 minus 8, which in this case is 42. And my range will be 70 minus 1, which is 69. Okay? So those are my first 5 basic pieces of information. Again, we'll dig into outliers a little bit more in another question in a second. All right. Go ahead and take a look at this data. Again, it's already ordered from you from least to greatest, and determine what are those 5 measures of variation: the median, quartile 1, quartile 3, the IQR, and the range. And remember, I already kind of mentioned earlier, there are no outliers in this set of data. All right. All right, so pause the video and find those 5 answers for me. All right, let's take a look at those now. So I have a median. They're already listed. So my median is going to be right here in the middle, and halfway between that data is 73 and 5/10. Okay. Quartile 1, the bottom half is going to be 44. My quartile 2 is 88. That makes my IQR 44. And my range, 104 minus 38, is 66. So there's all my 5 basic measures of variation. Excuse that line. Let's go ahead and take a look at examining outliers this time. So to do the outlier, the formula is you take the IQR times 1.5, and you're going to add or subtract it from the quartiles. So you really need to find most of the measures of variation, except range, to be able to find quartiles. So we're going to look for the median, quartile 1, quartile 3, and the IQR before we can do any other work. So we find our median. In this case, it's 55. Our center point of data is 48. Our center of the top is 63. The difference between the two is 15. So now that I have all of that ready, I can use this to get my information. So I'm going to take 15 and multiply it by 1.5. And that gives me 22 and 5/10. So that's my distance that I'm going to go below quartile 1 to see if there's an outlier. So the first thing I'm going to do is to do quartile 1 minus this number, okay? Which I'm going to call the outlier number, the O number, okay? So I'm going to do 48 minus 22.5. And when I do that, I get a number of 22 and a half. I'm sorry, not 22 and a half. I'm sorry, I don't know what my brain was thinking. 45 and a half. No, that's still wrong. 25 and a half. There we go. I'm sorry, it's been a long day. So the lower limit of my quartile range, or my outlier range, is 25 and a half. To find the upper limit, I'm going to do Q3, and I'm going to add the outlier number. So I'm going to say Q3 is 63 plus 22 and a half. So together that gives me 85 and 5/10. So this is my range. If I have any number outside that area, that's why it's referred to as an outlier, then it's considered an abnormal piece of data. It's an extraordinary piece of data. So we do happen to have one of those. In this case, our outlier is 23. It is outlier. It's too far. It's way far out. It's not inside the normal bounds of answers for this particular set of data. All right, it's your turn to try to figure this out. Remember, you have to find your quartiles, your median, and your IQR before you can do your outlier. All right, pause the video and find me if there are any outliers in the data for the temperatures in July. All right, so this time, the first thing you had to do is put them in order from least to greatest so that you're able to work your numbers. So 90, 92, 92, 94, and 95. So these are my numbers. That makes my median right there at 92. It makes my quartile 1, 89. It makes my quartile 3, 94. And then that makes my IQR 5. So I'm going to multiply this. So 5 times 1.5 is 7.5. So I'm going to do the same thing I was doing earlier. What's the distance? 89 minus 7.5 is 81.5, or 81 and 5/10. And then 94 plus 7.5 is 101.5. So if we look at our data points here, we need numbers. Are there any data points outside below 81.5 and above 101.5? And there is. So therefore, we have one outlier as 71 is our outlier. All right. So let's go ahead and take a look at one more thing as we work. The table shows the set of scores for a science test. So with the science test, this is a way for teachers in multiple classrooms to say, hey, is this test valid? If it's taught by different teachers, different rooms, different kids, is it still a valid measure of their understanding? Well, one of the ways we do that is measure the variation and measure the measures of center on each set. So the first thing you have to do on both of these is put them in order from least to greatest. So I went ahead and did this already. It's 65, 67, 72, 87, 78, read my numbers backwards, 80, 84, 87, 92, and 100. Okay, and then set B was 63, 65, 73, 79, 81, 83, 87, 93, and 98. So this gives me my order. So now I can find my measures of variation. My median, my Q1, my Q3, my IQR, and my range. Now, I'm going to tell you right now, again, you are going to check for outliers on yours, but there are no outliers in either of these sets of data. Okay? So, if we take a look at this, let's find our median. So the middle number right here is 80. Our middle number over here is 81. So one thing we notice if we contrast it, Class B has a slightly higher center point, median, by 1 point. Q1 on this case is going to be right here, halfway between 67 and 72, and that's 69.5. Okay? Over here, it's halfway between 65 and 73, which is an 8-point difference, which is 69. Okay, so Class A has a slightly higher quartile. The top 25, low 20, the middle 25, the 25th, lower 25th percentile is a slightly higher in Class A. So one of the things we're thinking, okay, probably the grades are a little higher in room A. Let's see if that holds true. All right, our upper quartile is between 87 and 92. So our third quartile in this case is 89.5. Our quartile here is 6 this time, so not 6, I'm so sorry. Yeah, 6, which makes my third quartile 90 on this one. Okay, so now we move down, so I have a slightly higher upper quartile, so maybe I have higher scores at the top. My IQR here is 20. My IQ here is 21. My range is 35 for both of them. So what I could tell you in words is, hey, my median is slightly higher in Group B. My quartiles are slightly higher, elevated in quartile 3 on Class B, but slightly higher in quartile 1. My IQR is slightly different, is a little bit wider range for the 50% on room B, but their ranges are roughly the same. Overall, this data is very, very similar. So I would say the classes are pretty similar, the data is pretty similar, and the classes, this is a valid test. Like multiple kids in multiple classes got roughly the same scores. Not exactly the same, but pretty close mathematically. All right, it's your turn to try the same thing. Using this information, compare the two ages in the two different dance classes. Pause the video and see what you come up with. All right, so for ballet, again, first thing we have to do is put them in order. 15, 16, 16, 17, 17, 18. And for hip hop, you have 12, 13, 13, 13, 14, and 15. All right, our median here is going to be 16.5, where our median here is 13. Our Q1 here is 16, our Q1 here is 13. Our Q3 here is 17, our Q3 here is 14. Our range, sorry, not our range, our IQR is 1, and my IQR here is also 1. My range is 3, and my range is 3. So what this tells me, if I look at this, okay, well, the center point age in the hip hop class is only 13, where the center age in ballet is 16 and a half. The lower quartile, most students are over, 75% of the students are over 16 years old. Okay, and you'd say that 75% are 13 or more here. You could say that in Q3, the top 25% of the kids are 17 or older, and the next one you're gonna say they're 14 or older. The IQR, the distance, the center point, the classes are pretty close together. Their IQR is very small, so their numbers are relatively concentrated in their ages. And their range is 3, so they're basically the same size distance. One of the other things you would probably make in contrast is, hey, while the spreads are roughly similar, the age ranges are very different. The ballet students, it seems to attract older kids than the hip hop classes. All right, so now you've had a chance to look at the measures of variation. If you have questions, please reach out and come see me, and I'd be happy to help you.